Hello everyone, welcome to chapter 4 of our Java tutorial. Today I'm going to talk about variables and expressions. In fact, we have used variables and expressions also in the previous chapters, but today I'm going more into the details. Okay, so let's begin. Of course, you can use Java to do some calculation, and for that you need variables, mathematical variables, for example. So in this example, what we do here is that we have a variable a, that's the name of the variable. This variable has a certain type, namely int, that is the data type in Java to represent integers. And then what we do in the second line of code here is that we do the initialization of this variable. So we say the value of this variable is 2. The first line is the declaration. Here I'm just saying there is an int variable named a, and in the second line I'm saying the value of this variable is 2. So these are two different steps in Java, declaration and initialization. However, you can also nicely write that in one line, int a is equal to 2. Conceptually, it's good to know the difference, that there are actually two things happening in this single line of code, the declaration and the initialization. Okay, let's move on to a very simple example. It's again one class, namely our class test. It has this public static void main method that you know from the previous examples. And now we have an int variable a, which we assign to 2. Then we have an int variable b, which will get the value 3. And then we have a third variable c, and here we say the value of c should be the sum of a and b. And then what we do, we use our system.out.println method simply to print the result of this computation, meaning the current value in this variable c, to our system output. And that is what you obtain then here in my command window. If I'm running this program with the interpreter Java and the class name test, then I'm receiving here this value 5, which is of course the sum of 2 and 3. Okay, so that's pretty straightforward, of course. So if you see such a command, c is equal to a plus b, it's always good to know that this is actually an assignment. So what is happening here is that the right-hand side here of this equation symbol is evaluated first, a plus b, that is evaluated, and the result of this evaluation is 5. And then this result is assigned to the variable c, indicated with this red arrow here. So such assignments you always need to read from right to left. The assignment operator is this equation symbol. Okay, and then, well, here we still then place this variable c in these round brackets, meaning this variable is then read, the value is read and printed to the system output. But what I can do also is just within these round brackets to place a plus b. So what is happening then is, well, this sum a plus b is evaluated, the result is 5, and this result is then passed over to this method print line, which is then printing this result 5 to my system output. Well, something more I can do here. So here I have the same computation as before. Variable a of type int is equal to 2. Variable b is 3. c is a plus b, meaning that will be 5. And now I am defining here a variable of type string. The name of this variable I'm choosing output. Well, yeah, so of course that's a meaningful name because that will be the output of my computer program. And then here, so the value of this variable, that is what you see here on the right-hand side of this equation symbol. Yeah, so this expression is evaluated first, and then it's assigned to the variable output. And then this variable output is simply passed over to this method print line, which is then reporting the value of this variable here on our command window. So all what we need to understand now is actually what is happening here, what is happening in this expression. Well, and what you can see here, this one, basically these three symbols, yeah, so it's a blank space, the plus, and another blank space. And these three character symbols, they are wrapped within these parentheses. Yeah? And these parentheses, they are always used for strings. So this indicates that a string with three characters, namely blank space plus blank space. And similarly, this is also a string with three characters, blank space, equation symbol, blank space. And what is happening here with these plus symbols, now it's basically doing a concatenation of strings. So it's concatenating the value of A with this string, with the value of B, with this string, with the value of C. And accordingly, what you get then is a very nice output, namely 2 plus 3 is equal to 5. This is then a string of 1, 2, 3, 4, 5, 6, 7, 8, 9 character symbols. Yeah? So that is now the string here in my variable output. And when I'm passing that to my print line method, exactly that string is then printed in the command window. Okay, so this is a very nice way to use Java kind of as a pocket calculator. Well, you can do all kinds of computation with this, of course, multiplications, subtractions, divisions, or additions as in this example. Well, okay, let's continue to a more complicated example. Here I'm having 4 variables. Each of these variables is of type double. That's a double precision floating point number. So that's the type I'm usually using for decimal numbers. Here 2.0, 2.0, 6.0, 5.0. These are the values I'm assigning to these variables. The variables are x1, y1. These could be the coordinates of a point P1. Then we have x2, y2. These could be the coordinates of a point P2. And now a very common problem in geographical information science or in geodesy is, of course, to compute Euclidean distances between points. And exactly that's what I'm doing here. So yeah, what do you need to do to compute the Euclidean distance? You need to compute the difference of the x-coordinates and need to compute the power compute this to the power of 2. And then you need to compute the difference of y-coordinates to the power of 2. Yeah? And this to the power of 2, yeah? So that is what is computed with this method POW, P-O-W. Yeah, so this method math.pow, it requires 2 arguments, namely the base and the exponent. So here the base is this difference and the exponent is 2. So it's computing x2 minus x1 squared. And accordingly, this method call here, it also takes 2 arguments, namely the difference of y-coordinates and the exponent 2. So it's computing y2 minus y1 squared. Then to compute the Euclidean distance, you need to add these 2 terms and compute the square root of that sum. And that is precisely what is done here with this expression. So we are computing, so to say, delta x squared plus delta y squared, and of that sum we compute the square root. That is the distance between the 2 points, and this result I'm assigning here into this variable s12. It's the distance between point 1 and point 2. And now, of course, I would like to report this outcome of my calculation. For that, I'm using again this system out.println method, and into these round brackets there, I'm placing what should be the output. And that's again a concatenation, namely of a string and the value within this variable s12. Accordingly, if I then execute the program, well, first of all, I need to compile the program, but then if I execute the program, I'm receiving here this output. S12 is equal to 5.0, which is actually the distance between the points defined with these coordinates. Now that's how we can calculate with variables. Well, you see there are these important math functions, sqrt for square root, po for the power, and in this class math, there you find many more important math functions. For example, the sine function and cosine function, things like this, which you need very often in calculation tasks. Okay, so what we need to understand if we do such programming and if we implement more complex programs is, of course, that very commonly we will make errors. That is unavoidable. Yeah, it's rather an exception that I'm writing down the code and it is correct from the beginning. Usually an important part of software development is debugging, finding errors and getting rid of them. And in Java there is a difference between errors and exceptions, and that I would like to explain now with this slide. So first of all, if you see here this code, it seems to be the example that we've seen before, but there is a slight difference. Actually here you see after this command I removed this semicolon, and that is an error. Yeah? So in Java every command needs to be terminated with a semicolon, or it needs to end with a semicolon. So now if we try to compile this class, we will get an error message that you can see here. So I'm using the Java compiler, Java-C, for my file test.java, and well, the compiler is very good, not just in recognizing that there is an error, but also in telling me what kind of error the compiler has found. It's saying here in my file test.java in line number 4, there is an error, namely there is a semicolon expected, but it's missing. And you see this little arrow here, it's actually pointing precisely at the position in my code where that error occurred. Now my task is, of course, to fix the error, to compile the code again, and then hopefully it's compiling without error, and then I can run the program. Well, another example. So here you see I have the semicolon. So that's not the error anymore. But what I'm doing, I'm saying there is a variable a, which I initialize with value 2. Then I have a variable b, which I initialize with value 0. And now I'm trying to compute the division of a by b. Yeah, a divided by b. And the result should be assigned here into this variable c. And then I just want to report the output to the system output or to the console. And if I'm now compiling this class, well, that is compiled without error. Yeah, so the Java-C command, well, correctly compiles my source code. But now, if I try to run the program with the Java interpreter, there I will get an exception. And that is here, exception in thread main. So in my method main, there is an exception. And this exception is of the following type. It's a Java lang arithmetic exception. So something went wrong during such arithmetic calculations, namely division by 0. Of course, in mathematics, if you divide by 0, the outcome is undefined, and accordingly here in the Java program, an exception is thrown. Yeah, so that is happening during the execution of the program. And that can lead to a program crash. Yeah, so the program terminates. Well, that's of course not so nice. Therefore, when implementing Java programs, you need to deal with possible exceptions. So there's a whole chapter about how to deal with exceptions. For the moment, it's sufficient to know how to read these exceptions and to understand what went wrong, and then you realize, okay, yeah, maybe I should not divide by 0. But there are also ways to catch these exceptions and to deal with the exceptions during the execution of a program. For the moment, I would just say try to avoid such exceptions. Okay, just one final thing. I'd like to talk about comments as well. That is very important to improve the readability of your code. Maybe you do the implementation today, and tomorrow after a long night you wake up, you want to continue working on your code, and you don't understand at all what you did yesterday. Yeah? And therefore it's important to augment your code with comments. It's even more important if you work in a team. So maybe you did some implementation and someone else should now continue working on this. Of course, then it's important that this other person understands what you did. And for that we have comments, one-line comments. They are quite common. For example, here int a is equal to 2. Of course, we know already that's a declaration and an initialization of a variable, but just to make sure that everyone else understands what we are doing, we can write a comment, an integer variable with the value 2. That is introduced in this line. Yeah, so this comment is not very reasonable because everyone who has some very basic understanding of Java will understand what is happening here. But if you have complex calculations, it would be, for example, reasonable to say, here in this line, I'm computing the Euclidean distance between 2 points. And then you type in Java the command, the expression to calculate the Euclidean distance. So that's a one-line comment. In Java there are also multi-line comments, and they are wrapped within these character sequences here. So basically the slash and this star, the asterisk symbol, they indicate the beginning of this multi-line comment. Then this asterisk and the slash, that indicates the end of such a multi-line comment. And everything in between is part of the comment, meaning the comment, of course, is not compiled by the compiler. It's simply ignored. It's just for humans to understand your source code. Often you see this multi-line comment also in this form. Well, this is of course the beginning, this is the end, this is just some decoration, so to say, to make this look nice. Yeah, so this has no meaning or no effect actually. It's just, well, maybe highlighting that there is this multi-line comment. Well, what is also important, of course, comments are one way to improve the readability of your code. But there's also another way. And that is, of course, we are rather free in choosing the names of our variables. We could say int a is equal to 2, but we could also say int height is equal to 2. For the compiler and interpreter, that doesn't make any difference. But for the human who has to read and understand your code, that is very important, this difference. Because now that I have variables height and width and area as the product of these two variables, Now I'm understanding what's going on here. So someone is computing the area of a rectangle, and height is the height of the rectangle and width is the width of the rectangle. So choosing names of variables and names of classes in a way that this is kind of self-explanatory. And so that is also important to make your code readable. Well, just to summarize this example here, of course, as output then, with system out print line, what we get is an area is equal to 6 square meters. And so that is produced with this line of code. Yeah, I said we are pretty free in choosing the names of our variables. However, there are rules. Yeah? We cannot choose every character sequence as a variable name. So there are certain names which are not allowed. For example, allowed is hello world with underline, or we can also begin a variable name with an underline. We can also choose hello 123 or hello underline 123. That's all possible. But what is not possible is to begin the name of a variable with a number, with a digit. Yeah, so that's not possible. Maybe I have a variable which should represent the number of students in Cologne. And now I'm thinking of a reasonable variable name for that. And I'm saying, okay, students in Köln. Köln is the German name for Cologne. It has this special character Ö. And that is also not allowed in Java. Yeah, so special characters like this you cannot choose in your variable names. Hello world, yeah, so that's also not allowed because it has this blank space here. Yes, so that must not be included in one variable name. And finally, there are these keywords in the Java programming language, like class, public, double, int. Yeah, so these words are reserved for the Java programming language. So of course, such words you can also not choose for variable names. Well, this is just a small number of examples. If you would like to have a complete overview, please check the Java documentation. There you can see more about what variable names are allowed and what are not allowed. But maybe you just do this by trial and error, because the compiler will tell you, of course, if you choose a variable name that is not allowed. Then you will get a compile error. Well, finally, what is important also in Java is there are some style recommendations. So that's not a strict rule, but it's a good Java style to follow these recommendations. And especially there's the recommendation to choose lowercase letters for variable names. So for example, S13 with lowercase s. And capital letters should be used for class names. So for example, for the class test. That makes it very easy then to differentiate between classes and variables, of course. Yeah, if it is lowercase, that's a variable. If it's uppercase, it's a class. But that's just a recommendation. Okay, so that was chapter 4. For this session, that's all. But in the next session, I'm talking more about data types in Java. Thank you very much.